Last week, we spoke about the topic of elementary programming. So the essence of that would be you have a sequential execution of your program, and your program consists of data types, variable declarations, variable assignments, and also using casting or coercion when necessary. So these are the basic topics which I assume you already are comfortable with. And this week, we'll start talking about the topic called control structure, and selections will be the one to begin with. And later on, when we get to more advanced stuff, we need to talk about iterations, but one thing at a time. So first of all, let's clarify what the learning objectives are for this week. It's always important to clarify what we want to do for the week. So learning outcomes. Number one, we want to talk about the notion of Boolean data type. We talk about so far integer, character, and also double and string, and the basic one, right? We call the primitive data type, and also string is a reference type. So we're going to introduce a new one called Boolean data type. So this will be a very fundamental data type for both if statements and also loops, right? So we're going to pay attention to it. All right, we're going to introduce if statements, the syntax, and also its semantics or its meaning. And we're going to talk about compound versus primitive statements. So compound simply means you're going to build some complicated statements, just like how you build a complicated expression, right? You got expression versus compound expression. So now you got if statements versus compound if statement, right? Similar. All right, and then we're going to talk about logical operations and also common errors and pitfalls. So this will be the entire coverage for this particular lecture about if statements or selections. However, for this week, we may not be able to get to even logical operation. We'll see. Even if we get to logical operation, maybe just touch upon it very quickly, and then we have to finish the whole lecture possibly next week. We'll see whatever we can get into within 2 hours. All right, so again, before I start the lecture contents, I would like to remind you again, for those of you who might be ambitious and really want to do some extra practice to really master the ground stuff for this course, I have 2 recommendations for you right now, as in week 1. Number 1, so there will be one Java project archive file, lecture number 2, selections.zip. So where can you find this file? You can simply go to the lectures website and then look under the study material section for week number 2, and then you will see this particular zip file. And last week we showed you already how you can import this particular Java archive file into your Eclipse, and then you can play with it. Right? So throughout the lecture, for this week and next week, I might sometimes switch to Eclipse just to show you how you can trace the if statement program using debugger. So notice that your week number 2 tutorial videos actually show to you how to use debugger in Eclipse. So you may actually want to make sure you understand about how to use debugger before you actually go through the lecture. So that's my recommendation. All right, so we're going to talk about some example from your lecture notes, and the best thing you can do to really master program is to create your own examples. You really have to play beyond what I give to you, right? Always be curious. Okay, number 2, going to be optional but recommended. Remember this link I'm going to show you again. So this, again, is a tutorial series I recommend you try and also study. You can definitely get some extra hands-on experience about Java programming. And last week, I recommended you should really, you can try video 1 to video 7, right? Hopefully you got a chance to try. If you haven't, it's not never too late to catch up, right? If you want to do something extra. And for week number 2, what I would recommend would be you want to do from video 10 to video 17, just covering a Boolean data types, logical operators, and also the if statements, especially how you do nested if statements. So that's something I will recommend. Oh, actually, sorry, it's only the basic if statement. The nested if statement will be for next week, so not yet. So if you want to do something extra, just do from 10 to 17. That'll be sufficient for this week. All right, so that's about the extra practice. So let's now go dive into the lecture for this week. All right, motivating example. So why do we need a selection? So every time I introduce something new to you, you don't necessarily have to really take it for granted, right? You should always be suspicious about why we need selection. So I'm trying to justify right now to you by using 2 examples. The first one I will discuss in detail about without conditionals or without selection, you actually run into trouble in solving your computational problem in Java or in any programming language. All right, so let's now consider the first motivating example. And let's just go back to our famous week number 1 Java tutorial example, circle calculation. Okay, that's something you're familiar with already. Let's say we declare the scanner, and by the way, we are having some main method here, meaning that we're considering some console application, right? Interacting with the user from keyboard and also the console. We declare a scanner over here, and then we prompt the user to actually enter the radius of a circle. And then we assume the type of the input from the keyboard is going to be a double with a floating point, possibly, right, after decimal point. And we store the value into radius from user. And then declare some constant over here called pi, right? And then we are trying to calculate the area with a conceivable formula. And then, first of all, we print out to say circle with a radius, so this is the input from the user. And then that circle has an area of whatever area we calculate, right? Very simple. And then we close the scanner, right? All right, first of all, just as a reminder, when the above Java class is run as Java application, you're going to do sequential composition. You go from line number 4, followed by line number 1, line number 6, all the way to line number 11, right? Execute line by line, okay? And now, in line number 6 over here, we actually try to read some value from the user, right? And do you see any potential problem? For those of you who might be able to see what the problem is, that means you're good. You're good to really justify yourself why we do need selections. But if you don't know, why don't we try very quickly, right? I would like to go to Eclipse first, and then I'll try to trace some program together with you. All right. Okay, so that's a tutorial page you know about. So this is basically the second week Java project I made available to you, right? You can import it as I mentioned. All right, so now let's first of all look at we got many files over here. Let me look for the first one, circle app, no selections. Okay, double click over here. So that's exactly what I just talked about. All right, and then I'm going to actually trying to run. By the way, if you see errors over here, that's okay. That's only the errors from week number 1, where errors are actually expected to show you compile time error. So don't get confused, right? All right, so now let's see the console over here. So I want to run this particular program. All right, so now let me right click on that, and then I'll say run as Java application. All right, enter the radius of circle over here. Let me maximize the console over here. Okay, radius. If I try 3, all right, and it will be this particular value. You can double check that's actually correct. All right, so now this is actually okay, but this is actually not a problem I'm expecting you to tell me, right? This is not a problem, right? Apparently that's correct calculation. What if I try the following? What if I try -3? Notice that over here in the program, it's only reading a double from the keyboard. It doesn't say the double itself has to be positive or at least non-negative. So now if I say -3 over here, it says circle with radius -3.0 has an area of 28.26, which doesn't make any sense at all, because how can a circle with negative radius just be valid to begin with? So there should be no area. They should have been just an error message printed out to the console. But at the moment, we just cannot use it by using a elementary program without any branching. All right, so let me summarize the point of this particular example, and then we can move on. So you can see this. What's happening over here is this. So the first input I tried is the radius of value 3, meaning that the user from input next double, they actually enter into the keyboard 3, or 3.0, right? Coercion will be done in this case. And then, so this radius from user is simply just 3. And then when we calculate over here, the area is just going to use 3 times 3 times pi. And then when you output the area, is absolutely no problem. All right, that's okay. However, the problematic case really is when we actually get -3 over here. You can see when we actually get -3, we're going to get 28.26. But it should not be the case because there's no area. So what's going to happen is this. It's going to be a sequential execution of your code line by line without conceptually jumping particular line. For example, you can see over here, let's say after reading the user entering -3, meaning that -3 will be stored over here. However, you can see this part of the code over here. Let me just show it to you. You can see this part of the code over here. Let me just show you over here. You can see, let me just write it down over here. This block of the code, the one I just highlighted in pink, they will still be executed despite that input radius is actually less than 0, which means it's invalid. So we want to say we only want to execute this block of code over here under certain circumstances. What kind of circumstances? We want to say only if the value of the radius is actually positive, or at least it's not negative. It's just not negative, right? If it's not negative, we're going to execute this block of code. But if that's otherwise, if it is negative, for example like this, in that case, we want to execute something alternative, right? So that's what we want, okay? In this case, an alternative block of code should be executed. It's a very simple example I'm trying to illustrate over here, but I really illustrate the very need of being able to take some alternative action. So over here, the keyword really is about alternative. To say whenever you want to execute your code, you should really have maybe some branching path. So at this point over here, let's say you're at this point for your program over here, you want to be able to either go this way or go that way, depending on certain conditions at this particular point of execution, right? It's called branching. Let me just write it down over here. You want to be able to branch, do branching over here. So that's really the keyword, keyword thing over throughout this lecture over here. All right, that's enough about motivating you for really using if statements. I know you might have already seen if statements in your previous programming experience or programming courses, but the reason I still want to talk about motivation is it's really important for you as a scientist to really know why you're doing a particular thing, right? You should always be suspicious about why or why not. All right, so that's about the motivation, right? And another one here, I'll just talk about it very conceptually, right? Let's say you, okay, so these are simply just the ones I talk about, right? I'm gonna move on. The second example over here. Let's say we want to take some integer value from the user, now really floating point, and then we want to output a message indicating either the number is negative, alternative number 1, 0, alternative number 2, or positive, alternative number 3, meaning that you can see just from the informal description of the problem you're trying to solve, you got 3 alternative outcomes for the program. So this just cannot be solved by what you learn from elementary programming. You need some branching structure like if statements for you. All right, so for example, if you enter 5, the output should be you just enter a positive number, right? That's one possible outcome. Or if you enter -5 over here, then it should be negative. You can see this is alternative number 1, this is alternative number 2. All right, or maybe if you enter 0, it should really be alternative number 3 to say that the input is actually 0. All right, so the lesson is your solution program must accommodate all the possibilities, all the alternatives. All right, I'm not going to show to really show you why elementary programming cannot solve this, right? It's going to be a waste of our time. So I'm going to move on. And then at the end of the lecture, if you look at the beyond the lecture section at the end, so I do assign some extra practice for you. You can try to, once we learn about how to use if statements, you can try to program the solution for this. I'll leave that to you. All right. All right, so far you only learned about writing programs from elementary programming that are executed from top to bottom, line by line, without ever branching, right? Again, it's really important concept over here. You're simply doing a sequential execution over here from top to bottom, line by line, right? Meaning that either for legal input and also for illegal inputs, the execution path are exactly the same. They always execute this particular block of code. There's no way to really distinguish between legal and also illegal action over here. So what we really want is to have a way to say, this is the block of code I want to execute when the input is valid. There should be another block of code I can specify to say execute it if the input is invalid. Okay, that's again just to reinforce. Okay, in general, we need a mechanism to allow the program to check a list of conditions. So now, when we say branching, right? So here, the diagram I drew over here, simply you can either branch to outcome number 1 or to outcome number 2. In general, the number of possible branches you can have is unbounded, right? Well, when I say unbounded, I really meant you can have as many as you like, depending on your application need, right? You can say, at this point over here, I'm going to check many conditions. I can either go for alternative number 1, number 2, number 3, all the way to number n, right? It can be as many as you like, as long as it's logically correct. All right, and then branch its execution accordingly. So selection is really about branching, right? So that's we'll see many examples this week and also next week to see how you can branch differently. And also there will be many cautions you have to take when you write if statements. All right, to solve the above problem, we have 3 branches over here. You can go over these 3 branches, and this will be a hint. When we get to the end of the lecture, there will be some extra exercise for you to solve. All right, so that's about the motivation. So now let's talk about Boolean data type.